What kind of figure do we have? It is a quadrilateral. Can I be more specific than a quadrilateral? Okay. Do we know for sure that it's a square? Yeah, we could actually get to that point, and you might say, well, there's only one 90-degree angle, okay? But what we know here is we may not be able to get to the fact that it's a square, but if this is 90, what's this angle up here? 90, okay? And what do we know about consecutive angles in a parallelogram? They're supplementary, right? They're 180. And so I know these are both 90, and I know these would have to both be 90 as well, and these would both have to be 90. So how we can use that in this particular instance is, let's go angle 2, first of all. What would be, and we saw a problem like this last week, but we didn't spend a ton of time with it. What would be the measure of angle 2?
39 degrees.
39 degrees. How come, Corey?
Alternate interior angles.
Yeah, perfect. 39 degrees because they're alternate interior angles. Okay, and that goes way back to first semester when we talked about all those relationships, alternate interior, consecutive interior, corresponding, those kind of things. If we have parallel lines, we can use all those angle relationships, right? And that's a really big deal. Now, the fact that this is 90, and I know this entire angle also has to be 90, then these two together must make 90 as well. So we would say these two are complementary. So then that would leave us this angle here to be 51. And then this angle here would also be 51. Okay, and if we had to, I know it's not asking us to find this, but we could find this angle here also, which is 90. So we have a parallelogram. The reason we can't necessarily say this is a square is we don't know the lengths of the sides, and we're not doing anything with the lengths of the sides. So we can prove angles, but we don't know for sure about sides. And that's where today's information is going to kind of come in to play. A rhombus is a parallelogram with 4 congruent sides. Okay? A lot of times when we see 4 congruent sides, immediately we think square. The difference between a rhombus and a square is a rhombus doesn't necessarily have to have 90 degree angles. Okay? We do not have 90 degree angles in this picture as opposed to this one we do. Okay? So basically what's going on here is a square is a more specific rhombus. Okay? We have rhombus, and then we have a square. So a square is a rhombus, right? Because it's a parallelogram with 4 congruent sides. A rectangle is one that we've seen a ton. We see that way back when, even in grade school, we talked about rectangles a lot. What makes a rectangle is, notice that on all 3 of these, the definition uses the word parallelogram. So once again, we've talked about parallelograms for like a week now. All of these are parallelograms. Okay, and the reason I point that out is because if all 3 of these are parallelograms, then all 5 of those properties that we put onto our foldable, all of those are true about all of these figures. Okay? If I have diagonals, the diagonals bisect each other. Opposite angles are congruent. Consecutive angles are supplementary. Because all 3 of these are parallelograms, they have all the properties of a parallelogram. So it's like a parallelogram plus something else, right? Not only is it a parallelogram, but we have some additional information added on to that. And so here's what I'll tell you about a square. Okay, a square is a parallelogram, it's a rhombus, and it's a rectangle. It's all of those thrown into one. Because it has opposite sides that are parallel, it has 4 congruent sides, and it has 4 right angles. And so one of the ways that I kind of think about doing this, and we'll look at the Venn diagram here in just a second. Parallelogram is where we could start. All of these are parallelograms, okay? And then you could say, is it a rhombus? Or you could say, is it a rectangle? And then what's kind of weird about this flow chart is if you say yes to both of these, yes, it's a rhombus, yes, it's a rectangle, then those two come back together and they make a square. I could say, yes, it's a rhombus, and no, and not a rectangle, then it would be a square. I could say, yes, it's a rectangle, but not a rhombus, and then it would just be a rectangle, okay? Or it could just be a parallelogram. It may not have any of those things. It may not have 4 congruent sides or 4 right angles. Okay, so as we look at our pictures today, we're gonna have to make some decisions about what do we know about this parallelogram? What are some pieces of information that we already know or can prove about it? Here's another way of putting all that together. Parallelograms is like the big box, okay? And we kind of threw some examples of parallelograms in here. That's just a basic old parallelogram, okay? If all 4 sides of the parallelogram are congruent, then it's a rhombus. If all 4 angles are 90 degrees, then it's a rectangle. And a square links those together. A square is a combo of all of those. So the inner piece, the square here, belongs to all of those things. It's a parallelogram, it's a rhombus, and it's a rectangle. So keep that in mind as we talk about squares. Squares, if I say that a figure is a square, then it has the properties of a parallelogram, a rhombus, a rectangle, and a square, okay? It has all of those things. Okay, we've seen some corollaries. This is just like an additional piece of information. It's not really a theorem, but just another piece of information I can throw into the mix, and I know this is true. And here we're saying a quadrilateral is a rhombus if and only if it has 4 congruent sides. So if I look at a 4-sided figure and I see that it has 4 congruent sides, immediately I can say that it's a rhombus every time, okay? If I look at a 4-sided figure, a quadrilateral, and I say this has 4 right angles, immediately I can say that it's a rectangle. Okay, so this one's a rhombus, this one's a rectangle, and if I look at a 4-sided figure, and that 4-sided figure has 4 congruent sides and 4 right angles, immediately I can identify that to be a square, okay? So what kind of markings does it have on it? If the markings aren't there, then we have to decide, do I have enough information to prove anything? And if I don't, then we may not be able to prove. So the hardest part here is don't always go off of looks. I know we've said that a lot throughout the year. Sometimes when you look at a figure, it kind of looks like it's a square, but we need some information to eventually get there. Okay, these problems here I think are a little bit tricky. It says, is this always, sometimes, or never true? Always means it's true 100% of the time. Never true means it'll never happen. Sometimes means it could be, but not always, right? Somewhere in between. Angle Q is congruent to angle S, okay? We have a rhombus. Q, R, S, T. And it doesn't really matter where you start at here. Are Q and S always, sometimes, or never congruent? Okay? Because this has 4 congruent sides, what would we call this figure? It's a rhombus, and it tells me it's a rhombus, right? What do we know about a rhombus? What's the definition of a rhombus? 4 sides are congruent, and it's a parallelogram, right? So a rhombus is a parallelogram. Well, what do we know about the angles in a parallelogram? What do we know about these opposite angles? They're equal, right? We know this figure is a parallelogram, and in a parallelogram, opposite angles are always congruent. That's one of the properties of a parallelogram. Opposite angles are always congruent. So for this one, we would say this is always true. And because QRST is a parallelogram, and we know in a parallelogram, opposite angles are always congruent. Every time, okay? So just keep that in mind. If they tell me it's a rhombus, which they do, that's stated right here, we know it's a rhombus, then we know it's a parallelogram. And so just think about, what do I know about a parallelogram? Those are things that we've been talking about for the last week. So just remember the properties of a parallelogram. Once again, that's why we make the foldable. You can go back and look at those properties of a parallelogram and remember those things, because there's going to be a ton of information throughout this chapter. Okay, same picture here, QRST. I'm not going to redraw the picture. What would I say about Q and R? Are they congruent? And in the picture that I have drawn right now, are Q and R congruent? Okay, and I know it's hard to look off of pictures, but right now, are they 90-degree angles? No. Okay, this could be like maybe 120. It looks like an obtuse angle. This would be like an acute angle. Okay, what do we say about consecutive angles in a parallelogram? They're supplementary, right? These two are going to add up to be 180, right? So right now, could they be congruent? What would make these two congruent? What kind of angle would it have to be? They would both have to be 90, okay? And so on this one, we're going to say sometimes. If I draw a picture like this, and I have a rhombus, now consecutive angles are supplementary, right? All four angles in that picture are 90. Is this still a rhombus? Yeah, okay. But what else have we added? We've added that they're 90-degree angles. Not every rhombus is going to have 90-degree angles. This one does not have 90-degree angles. We don't know what the angles are, but they don't have a right angle in it, right? So we can't assume or guess that they have 90-degree angles, okay? And so my reasoning here, I would just say something like, if the rhombus is a square, then all angles would equal 90 degrees. If the angles are not 90, then they would not be congruent. So pay attention to where like Q and R are at. Q and R would be those two. About on that previous page. If I have a four-sided figure with four congruent sides, I can call it a rhombus. So if I have four congruent sides on a four. Hey, once again, I do feel like drawing a picture is helpful, right? I'm a visual person, and geometry is a visual class. Trying to imagine what it looks like without actually having a picture, I think, can be really difficult sometimes. But if I have a picture in front of me, and I can see what we're talking about, and I can see what we're doing, I think things make a whole lot more sense. So in this case, we have a square. Well, what are some things that we know about a square? What are some markings I could put onto this figure? What'd you say? Four congruent sides, good. Okay, that'd be a good start. Okay. What else is true about a square? All 90 degrees. Good. Okay. So we can go ahead and do this. And we're only able to do this because it says that it is a square. We know it's a square, so we can put all that information in there. And I would say go ahead and do it, right? Label the sides, J, K, L, and N. What's the symbol that we got right here? What's that upside down T? Perpendicular, okay? Perpendicular means what? They make 90 degrees, okay? Two lines form 90 degrees. Are JK and KL perpendicular? Do JK and KL form a 90-degree angle? Yeah, okay? In a square, will those two sides always form a 90-degree angle? Yeah, because all of our angles in a square are always 90, right? And so this is always true. All angles equal 90 degrees. So those sides will always be perpendicular to one another. I could say the same for any of those sides. All four sides would be perpendicular, okay? Okay, this next one, a rectangle. Draw yourself a rectangle. Label it E, F, G, H. On problems like this, the biggest issue that I see a lot of times is we don't take the time to draw the picture, okay? And some people can do this without seeing a picture, but I think in most cases, seeing a picture is going to be much more helpful. What are some things that we know about a rectangle? All the angles are congruent. All the angles are 90, okay? A rectangle has 4 right angles. It's asking me if FG and GH are congruent. In the picture that I have drawn here, are FG and GH congruent? What do you guys think? I mean, I know we don't have anything labeled, but on all rectangles, will these always be congruent? No, because think about what a rectangle usually happens. This might be 4 and this might be 7, right? These two sides don't have to be the same length. What would make FG and GH the same length? If it's a square, okay? If I were to redraw this picture, is this a rectangle? Here's where it gets a little bit tricky. Is this picture a rectangle? Do we have 4 right angles? Do we have 4 sides? That's the definition of a rectangle, right? 4 right angles, 4 sides. Okay? But what's more important? What's special about this figure as opposed to this figure? All the sides are congruent. So what does it actually make this figure? Square. What do we know about a square? A square is a rectangle. Okay? All squares are rectangles. Are all rectangles squares? Doesn't work the other way. Okay? So if I draw a square, every square is a rectangle. But is this rectangle a square? No, because it doesn't have 4 congruent sides. Okay? So that in this one, what do you think we're going to say? Always, sometimes, or never? Sometimes. Okay? It works sometimes if the rectangle is a square. If it's not a square, then it wouldn't work. Okay? So sometimes it works, sometimes it doesn't. And that's another reason why it gets a little bit tricky is some of you will probably draw this picture here, and then you'll say, oh, it doesn't work. Okay? I drew a rectangle, and these two sides are not congruent. Okay? Think about another way you could draw that rectangle. That's where it gets a little bit harder. All right. On this one here, they give us some information. All of the figures today are going to be 4 sides. Okay? So they're all going to be quadrilaterals. But we want to classify it the best way, the most specific way possible. What's the best way I could classify this? So right now, I know I have 4 congruent sides. If this is 70, then we don't know if this is a parallelogram. So immediately we're not sure if this is even 70, right? Because it doesn't tell me it's a parallelogram. But think about what we just talked about a figure, then the best way I can name this is a rhombus. Okay? Could I get more specific? Well, could this be a rectangle, or sorry, could this be a square? No. How come? It's 90. Okay, a square, I could get more specific and say it's a square if this is 90. But we know it's definitely not 90 because it says it's 70, right? All four angles would have to be 90. Okay, so rhombus is as specific as I can go. What is another name for an equilateral rectangle? What does it mean to be equilateral? All sides are equal, okay? So all sides are congruent. That's what it means to be equilateral. If it's a rectangle, what's that tell me about the angles? All 90 degrees, okay? All angles equal 90 degrees. So if I have 4 equal sides and 4 right angles, what do I have? A square. Okay. You won't see that word very often, equilateral rectangle, but that is what it is. When we talk about triangles, we've talked about equilateral triangles. Most of the time we just called it equilateral, right? We didn't say equilateral triangle. But what we said about an equilateral triangle is that all angles are also equal. And that's also true in this case. But not always, right? If it's a rhombus, I could have 4 equal sides, but not necessarily 4 right angles. A quadrilateral has 4 congruent sides and 3 angles that measure 90. Four congruent sides. Mark it up. 3 right angles. What does that 4th angle have to be? 90 degrees, okay? And there's a lot of different ways that we can do that. If this is 4 sides, that means it's a rhombus. 4 equal sides, I should say. And if it's a rhombus, it's a parallelogram, so that means opposite angles have to be congruent. That means consecutive angles have to be supplementary. Either way, it's going to get me to the 4th angle is 90, okay? So the 4th angle equals 90 degrees. Therefore, we have a square. Okay. So a lot of this is kind of proving, using the information that we know to get where we want to be or need to be. Okay. That's it for today.